Hey guys, so today we're going to learn about percent yield. This is a concept that is actually fairly simple, so I'm only going to spend today going over it. But percent yield is, we can make an analogy to our cookie example that we used at the beginning of stoichiometry, where we have our ingredients that we're making and we're producing cookies as our product. And our reaction doesn't always quite go exactly how we plan. So things might affect the number of cookies that we make. And so things like you might have batter left on the bowl, or maybe you eat some of the raw cookie dough, which is not very healthy, so you should not do that. Or you drop a cookie on the ground. So all these things would affect the number of cookies that you actually produce, making it different than what our recipe or what we calculate would be. So in order to show this with a chemical reaction, we use something called percent yield because the same concept applies for our chemical reaction. We might have chemicals that are stuck onto the glassware, it doesn't get mixed thoroughly, we drop some, so these things can affect it as well. So we use percent yield to show how much is actually made in relation to what we would expect to be made. And this is the equation for percent yield. You have your actual yield, how much you actually make, over your theoretical yield, how much you theoretically would be making, times 100% to make it a decimal. Sometimes you may see actual yield also referred to as experimental yield. It's meaning the same thing. It's what you are actually making with your experiment. So when you're doing these problems, your units for these, because it's a ratio that you're doing, the units don't really matter. You could have it in grams or moles. The important thing is that it's the same for either one. If you're given in moles, you need to have your actual yield in moles and your theoretical yield in moles. If you're given grams, you need your actual yield in grams and your theoretical yield in grams, because then your units will cancel out and you will be left with just a percent, which is what we're wanting. Okay, so here's an example. We have our equation and it's balanced, and it says you calculate how much N2 and H2 you need. So you have how many of the reactants you need to make 30 grams of NH3. However, after you do the experiment, you measure the mass of NH3 and you only have 27.0 grams of NH3. What is your percent yield? So this is where we're using our experiment of actual over theoretical. So the actual or the experimental in this case would be 27.0 grams because that's how much we made in the experiment, how much we actually made. So we'd put that on top. And then this is divided by our theoretical. And that's saying when we calculate where we should make 30 grams. So that's going to go on the bottom. So we have our actual divided by our theoretical, and then we just need to do times 100% to make it to a percentage. So if we use our calculator, we will do 27.0 divided by 30.0 times 100%, and we're left with 90. But remember that we need to also use the correct number of significant figures for this. And in this case, we have two different numbers that we're looking at, 27.0 and 30.0, but both of them have the same number of significant figures. They have 3, so our final answer should also have 3. So we will write that as 90.0%. So that means that we made 90% of how much we thought we would actually make. So this would actually be a fairly good percent yield. In an ideal world, if we had no error, we would have 100% yield, meaning we make exactly the amount that we thought we would make. But this is pretty close. We made 90% of what we thought we would make. So these equations are pretty simple. However, they can get a little more complicated because sometimes instead of telling you how much your theoretical yield is, like it did here, sometimes you're asked to calculate that. So I have an example of that here. So this one says if you use 5.0 grams of nitrogen and excess amount of H2, so you have plenty of H2 to make NH3, after you do the experiment, you measure and you have 5.5 grams of NH3 that you made. And it asks, what is the percent yield? So right away, we still need to do our actual divided by our theoretical, but we don't know what our theoretical is because we're only given how much of our reactant. We don't know how much of our product we could make with 5.0 grams. So we have to do a calculation, but these we have done before. So we are starting with 5.0 grams of nitrogen, and eventually we need our final answer in the same unit as our experimental value. We need it in grams of NH3. So just like we've done before, if we are starting in grams of something, we have to first convert to moles of that thing, then we can convert to moles of our other thing, and then we can finally convert into grams of our last thing. So this is our pathway that we're going to follow. And I'm actually going to go ahead and just use this to make our chart. So we're starting with 5.0 grams of nitrogen. The first thing we need to do is to convert that into moles of N2. And I actually already gave you your molar mass, but remember you would just look up the mass of nitrogen and then multiply that times 2 because there's 2 nitrogens. And that goes with our grams of nitrogen. So we have grams of N2 on the bottom, moles of N2 on the top so that our grams can cancel. And we'll put our number of 28.02. Give us a little more space. And then we put a 1 mole on the top. So now our grams of N2 cancel, and we're in moles of N2. So now we need to turn our moles of N2 into moles of NH3. So if we have moles over moles of something, this is where we're using our equation. So our N2, we look and there should be a 1 in front of it, and our moles of NH3 have a 2 in front of it. So for every 1 mole of N2, we make 2 moles of NH3. And in some cases, you could just stop here for your equation if you were given your experimental value in moles, but these were given in grams, so we need to convert into grams so that we can compare that as well. So our moles of N2 can cancel, and now we need to convert our moles of NH3 to grams of NH3. So we'll put moles of NH3 down here on the bottom, and we need the molar mass then for this, and I already calculated for that up here, but you would have your mass of nitrogen plus the mass of 3 hydrogens, and that's 17.04 grams per mole. And since it's grams per mole, we're going to put it up with our grams, so 17.04. I'll just put it on top. Grams of NH3 per 1 mole of NH3. And then our moles of NH3 cancel, and we're left with our grams of NH3. So we can go ahead and plug this into our calculator. So we have 5.0 divided by 28.02 times 2 times 17.04, and we get this number. We should have 2 sig figs, so 6.1 grams of NH3. So in this question, we are not done yet because it's not wanting how much we're making, it's wanting what our percent yield is. So remember that the amount we just calculated now is our theoretical yield. This is how much in an ideal world we would make exactly 6.1 grams of NH3, but we didn't. We only made 5.5 grams of NH3. So this is our actual or our experimental value. So we'll put 5.5 grams of NH3, and then we'll do that divided by our 6.1 grams of NH3 times 100%. And we can plug this into our calculator. Times 100%. And we get this number. We want 2 sig figs, so this will round to 90 as well. I didn't really mean for them all to be 90, so they're not all going to be 90, but just in these two cases, they both ended up being 90%. So that's how you solve these problems. So I have a couple practice problems for you guys to try. So you can try this question. It's already balanced for you, so you can go ahead and try to calculate the percent yield for this one. Okay, so this one you'll have your actual, which is your 12.7 grams divided by 15.0 grams, which is your theoretical times 100, and you should get 3 sig figs, so it should be 84.7%. And here's another question that you can try. Okay, so in this one, you first have to calculate your theoretical yield of zinc chloride. So you start with 5.2 grams of zinc chloride. You have to convert that to moles, so you use the molar mass of zinc. Actually, your mole ratio is 1 to 1 because there's no coefficient in front of our zinc or our zinc chloride. And then we have to convert our moles of zinc chloride into grams of zinc chloride by multiplying by its molar mass. So if you do that, you should get 11 grams of zinc chloride. That's our theoretical yield. And we actually produced 10 grams. So 10 divided by 11 times 100% is 91% yield for our percent yield. So I hope this was helpful in helping you learn about percent yield and what it is useful for. You can see that in this case, this second equation, or the second example, we had a 91% yield, and the one before it, we had an 84.7% yield. So the time that you were more efficient was the second time in your experiment because you made more in relation to how much you expected to make. So you were more efficient in the second one. So it can kind of be used to help figure out what things are affecting your percent yield so that you can maximize your yield. And this is really helpful with like commercial settings for making chemicals and things like that. So I hope this was helpful for you understanding percent yield.